Hey everyone, today we will be solving Secret from HackTheBox, an easy-rated Linux machine. Here I have ran Ruscan, which is a port scanner which allows us to enumerate what services are externally running on the machine. In this case we have 22 for SSH, 80 for a web server, and 3000 for some unknown server. Go ahead and scroll down and see what else is going on there. We have 22 for SSH as previously mentioned, nothing that interesting here, just some SSH details. We have 80 for the web server, running simply Nginx 1.18.0. And then we have a port 3000, which appears to be running some kind of HTTP service. Let's go ahead and check out the web enumeration stuff. I'll go ahead and run whatweb, which will basically tell me what's running on the machine. And I'll run GoBuster. GoBuster is a tool used to directory bust the web server, meaning basically it will go to a number of different directories and files and basically tell us what comes back and what's living on that web server. We can see here we have a docs, an API, and that kind of thing. We look over in the whatweb and we can see here the name of the web server. We have the title, the Nginx version it's running. We have X powered by Express. That tells us it's probably running Node.js and that kind of thing. Let's now go ahead and look at the web application directly via Firefox. Here we have the web application running on port 80. Now, an additional step I have done is I've got Burp Suite running, and basically what that means is it's going to pass all my traffic through port 8080 to this application. And this application will effectively just keep an eye on all of the resources I go to and also allow me to modify with web requests. But we'll come back to that later. Cool, I'll go ahead and now click some buttons. Go to introduction, installation, register user, and that kind of thing. Burp Suite will also do the rest. I'm going to go ahead and hit download source code here since we have develop your cool project fast. I'm going to go ahead and download the source code. Okay, it's letting us download something. I'm going to go ahead and right click, go to save link. So I can choose where the actual link goes to. Give it 1 second. Cool. We're going to go ahead and save it into here. Cool. Go to here. When it's finished downloading, I will give it a second. We'll go ahead and click introduction while it's doing its thing. Okay, cool. So we have, this is an API-based authentication system. And an API is basically a bit like a web server, web application, except it doesn't tend to have like a front end, like an interface like this. Basically, it's a system which allows you to programmatically talk to it. In this case, we're using the HTTP protocol, so it allows us to effectively send some data to an endpoint, for example, API user register, and then this is our data we're sending, and then that will then process it, provided that we have, the right authentication or that kind of thing. That is now finished downloading. So I have here some examples of the HTTP requests and that kind of thing, but I'm more interested in the source code. Let me go ahead and open the source code here. Let me go ahead and extract it to here. If it even lets me, extract here. Cool. We'll take a quick look at here. So we have a register user functionality, we have a login user functionality, and an access private route. Okay, interesting. Let's now go ahead and look into secret.http. We have a files. Okay. We have a local, there we go. Slight lag there. Okay. Let me go ahead and open it up in here. We can open up a new tab here. Go to box. We go in code into local web app. So we can basically see what's in the folder. Okay, interesting. So we have some Node.js in here. The reason I know it's Node.js is I can see we have packets.json and validation.js and that kind of thing. Really what I'm looking for is things that obviously tell me what's going on under the hood. In this case, we can see we're running Express and we're using Mongoose for like the SQL database, or I think it's MongoDB database, and that kind of thing. If we go over to roots, we can see we have an auth, forgot, private, and verified token. If we go over to here, we have an register user, login user, and access private. Basically the same thing. So we have register and login, and we have the same here. We have auth to effectively register, and then we have login too. Cool. Let's go ahead and look at what's going on, just to see if there's anything interesting to look at. Register, simply taking basically taking the request we're sending it. So we have the body of the emails, we have the body names, and the password. Okay, cool. Then we're basically creating a user and storing it in the database. Pretty simple. Here we have login, basically the same thing, except here we're passing the email and the password into the application, and then that will of course then log us in. The way it knows we're logged in or not is using a token. In this case, we're using a JWT token, and we can see here that it's signed with a token secret. Basically, we have this is what's inside the token, and then this is how we sign the token to basically stop you from being able to modify it in future. Cool. Let's take another look at somewhere else by actually trying to talk to the API itself. So in this case, what we can go ahead and do is we can go ahead and look at the available commands we have. So here we have, say, let's go ahead and register a user. So we want to making a post request to this endpoint and providing a name, email, and password. Now, we don't need this this documentation to see that. We can actually set it in the source code. We go to register, we can see that it wants a email, name, and a password. And if it doesn't have that, then it's going to throw an error, basically. So we can basically go ahead and replicate that now. So to make this simple, I'm going to go ahead and use curl. Go to API requester. So here we have a recbin.com. Basically, this will allow us to make a curl request to the application, and it will just basically save us a little bit of time in regards to actually putting the curl request together manually. Okay, cool. So we want to go ahead and take in the endpoint here, so there. Go ahead and type in secret. That will do me. I already have it in my history. Change this to post, make this content, the JSON. Go ahead and take this out here. Cool. And hit paste. Cool. Now if we go to generate code, go to curl and bash, we can check that curl x post. Content type, yep, cool, looks good to me. I'll go ahead and copy this. Go ahead and just close this down. Go ahead and hit paste. And here we have email already exists. We use the example one, so of course it's already going to exist. We'll go ahead and change this on root to be, say, Sakura. Enter, name already exists, okay, fine. We'll go ahead and change this to Sakura as well. If it lets me. Sakura. Enter. Cool, we have created a user, sweet. What's next? So, go ahead and check out the documentation. We have register, and we have login. Okay, cool. Same thing here, basically just API user login, that's okay. We'll go ahead and then just adjust this to be API user, change register to login, like so. Go ahead and just close this down. And we will also want to go ahead and just modify it so we're no longer providing the name. So delete that. Go ahead and enter. And here we have a token. Now what is this? So this is a JWT token. What does it mean? Well, basically it's a base64 encoded string of data which represents our session. We go ahead into BERT, we can go into decoder, like so, paste it, and go into decode as base64, and we can see basically what it means. We have algorithm H256, type JWT, some token, our name, and our email. And then some stuff at the end, which is basically how it's been signed. Don't worry about this for the moment. Now, this is a little bit ugly, so I'm going to go ahead and take the same request. I'm going to go to JWT.io. Now, funny enough, actually, because this is an easy box, the actual documentation kind of gives you the next step. So in this case, it wants us to basically go to JWT.io. This is the website that we're going to go to. You can see it here. And basically drop in our token, like so. Cool. You can see here, it's given us Sakura and our email. Now, it says here that we have an invalid signature. Basically, what that means is if we want to modify this, for example, change this from a 9 to an 8, it's not going to work, basically, because we can't sign it, it's not going to work. So in order for that to work, we need to have the token to sign it. Now, if we look in the code here, we can see here that the code actually refers to the token when it's created. So we have here, process env token secret. So here we have an env, and if we look here, we have an env file. Now we have here token secret equals secret. Now we could use this token secret, but to save time, I'm just going to show you the next steps. So basically, in this case, we have the word secret, but really this is no longer accurate. The application, the live application, isn't using secret as a secret. It's in fact using a different string. Now, how do we see that string? Well, that's where we look into Git. So with Git, basically, Git will allow us to have version history and that kind of thing. So we can't see it here, but this is actually indeed a .git folder. We go into our actual terminal, go ahead and close this, we do ls-la. We can actually see here in the local web, we'll see it into there. Do it again. We have a .git folder. Now, what that basically means is it will allow us to look at all the commits in previous history, meaning we can basically look at old versions of the this repository. So we can get to say git show, and it will basically tell us it will show us the most recent commit versus the one before it. So we have, like, for example, here, like before it used to say you are admin, flag will be here. Now it says welcome back admin, basically the before and the after. Now this isn't really helpful because there's not much really we can use here. However, we can actually look at, say, git logs. I think it's git log. Yeah, we can see here the commit. So here we have a message. Now we can view logs from the server. Another message remove.env for security reasons. Ah, interesting. So we actually have a reference here to them removing something for security reasons. Now, even though we can't physically see what this was, we can actually look into the git commits and look at the differences. So the diff file. The easiest way, in my opinion, to this is to use git head. So git head, tilde 1 will give us this. Git diff head will give us basically the most recent commit -1. We can do git head 2. And it tells us here we have a token secret, was secret, but it was previously this string here. Basically what that means is, in our case, we have this secret, but we can actually look at the old version of the secret. Go ahead and take this out here, and we can now go ahead and then re-sign our tokens, like so. Enter, signature verified. And that means we can now modify our token. Okay, so what does that mean? Well, basically what that means is we now need to look at the code and see how the code's working. So we can see, okay, we can modify the token, but we can modify the JWT, but what does that mean? Let's go ahead and do that now. In the code, we have a few bits and pieces that talk about authentication. Let's go ahead and have a quick read through. We have a register, nothing too interesting here, just register as a user. We have a login, also nothing too interesting. But then we have a forgot and a private. Interestingly, if we look in private, router.getPriv, we have a if name is admin. So for example, if this is admin, the admin, we're going to get an admin role. If it isn't, it's just going to give us a URI normal user. Okay, interesting. But that doesn't really mean much in the sense of telling us what we can actually do. It just says basically you're an admin or you're not an admin. There's no actual functionality we have created by doing this. If we scroll down a little bit, there we have a /logs. Now, if we look through here, we can see here that it's actually checking for admin. If name equals the admin, again, the admin should be here, then it means we're going to have access to run some additional functionality. Let's go ahead and basically modify our name to the admin. But before we go and do that, let's go ahead and actually make a request to the server using our standard Sakura account. Because I want to go ahead and obviously confirm this works. Okay, let's go ahead and do that now. We go over to the documentation and look for how we can make a request. In this case, it's get API priv. Okay, very simple. And then we should have an auth token. Fine. So just to make this a little bit easier, what I'm going to go ahead and do is I'm going to go ahead and just quit out of here. I'm going to go ahead and then export my HTTP proxy to be this. What this will do is it will basically pass our request via burp. It's important that we go via burp since we can see what's going on under the hood. And I think it's just a little bit easier to work with. Okay, cool. Looks good to me. Okay, so if we now make a curl request to say google.com, and we have our burp suite in proxy mode like so, it should then work. Okay, actually, it turns out we need to make a request to a HackTheBox, so it's a secret.html. Burp suite opened up and basically intercepted our request. If we now go ahead and hit forward, it will now then go ahead and make the request, and we now go ahead and get the response. Now, what I'm interested in this case, so we want to go ahead and basically authenticate to the box. I'm going to go ahead and do just simply like this, and then we're going to go ahead and modify this request as need be. So we want to make a request to API/priv. We'll go ahead and append that into burp now. By the way, I pass this into repeater. This basically allows us to modify the request and make repeat requests. Now we have an access denied to API priv. Okay, that means we need to provide an authentication token. In this case, we can go ahead and type in, I think it's authorization, like so, colon, auth, token, colon, and then our token. So we have the token here, like so. Hit send. Slight delay in the response, that means something might have worked. Maybe. Might also because I haven't added a new line to the request. Here we have an access denied. Okay. That's actually because we're using authorization and not this header. You can see here we have a header here of auth token. It shouldn't be authorization, it should be auth token. So the header should be called auth token and not authorization. So it's very important to read what it wants you to do, or at least guess. Okay. Go ahead and now go to burp suite, change this from authorization to auth token. Go ahead and remove the extra colon, go ahead and hit send. And now we have an invalid token. That basically means that our token has been a bit broken. It's also because we messed with that there. So go ahead and have another go. Colon, space, hit enter. Cool. You are a normal user, Sakura. Basically tells us our user. Fine. Go ahead and modify this now. We'll go into here. We'll change Sakura to underscore, please, sub. Cool. Seems simple enough. Go ahead and copy this. Go ahead into burp, replace it, hit send, description Sakura please sub. Now, if we didn't have the token, let's say like we didn't have the encryption token, let's say that we just deleted it, and we went ahead and changed this to please subs with an S, copied it like so. Assuming JWT hasn't cached the the token we used before, this shouldn't work. Okay, yeah, see, invalid token. We now go ahead and take in our previous the token we used before. Go ahead and undo this, like so. Now we change this back to subs, copy, go ahead over to here, and then paste it again. It should then work, because basically, we need that token to sign it. If we don't sign it with the correct token, it won't work. Okay, so what does that mean? Well, we know from the code that if we are an admin, as in the admin, we can access logs. And we can also access priv. We're going to get a different response. We're going to get a welcome back admin versus a welcome back user info. We'll go ahead and change this now. Go over to here, change this to the admin. If I can spell right, admin. Cool, go ahead and copy. Go ahead and put this into burp. Enter. Now we have welcome back admin. It also tells us that we're an admin. Cool. So from here we can then access from the code alone, because here we have logs. We can now access /logs because we are the admin. Cool. So now go ahead and change this to logs, and it now works. We got an error though. We got a command get log one line undefined. Basically, this is because in our code it's taking our user input of file. We can see here in the code that it takes a request user and a request query file. Basically what that means is it will take a file parameter in the query string. So when I say query string, I mean in this top bar here, so get API logs, file equals a. Now if I go ahead and say type in Sakura or please sub, for example, we can see here it's going to be reflected. One line please sub. Basically what that means is it means that we can actually inject our own content into this command that is run. And if we can inject our own content into a command that is run, we can then get RCE and then say do something else. Let's go ahead and append a semicolon ID. What a semicolon will do is it will basically say I'm done with this command, I want to then append another command to the command, and that will then run. If I now go ahead and do Control U, what that will do is it will basically just URL encode the semicolon, converting it into a URL safe way. So when it's transported via HTTP request, it will then be processed as a semicolon and not as the end of a terminator, which is what a semicolon is often used for, like so, like that. Go ahead and hit send, and here we get a UID 1000-if. That basically means that we have command execution in the sense of we appended our own ID command to the request. If you go ahead and highlight this, you can see here. We can see here it's decoded from here to semicolon ID, and that basically means we have RC. So how do we escalate here? So there are a number of ways to get a remote shell, a reverse shell in this case, meaning we have remote access to the system, which means we can obviously escalate to a higher privileged user or just read local files. I think the easiest way in this sense is to use the SSH way. Let's go ahead and do that now. The way that SSH works is it will basically check the ID, the authorized keys. So if I have my public key, which you'll see in a second, stored in the authorized keys of a local system, it most often means I can connect to that system. If I now go ahead and say cat here, go to cat authorized keys, you can see here that I have this key here. What that means basically is that this Kali machine can connect to my Kali machine with its private key. I want to go ahead and do the same basically and provide my public key to their authorized key. I'm going to go ahead and do ID, RSA pub. Cool. Go ahead and copy this. Before I can do that, I need to go ahead and actually make sure the directory exists. So if I go over to here and change this ID to makedir, which basically will create a directory, /p, which will create the directory if it doesn't already exist, tilde, which means basically the home directory, /.ssh, which is where the files are stored, for example here. We can then go ahead and create the this directory, but it's going to throw an error at us because we haven't done the request right. Go ahead and do Control U. That will add in the pluses to URL encode the spaces, and it should then work. Cool. Now that directory has hopefully been created, we can now go ahead and basically echo out to the authorized keys. So what we'll go and do is echo. We'll just do like echo AA to .ssh tilde .ssh authorized keys. And then we'll just take this, and then we will then obviously drop in our private key, public key, I mean, to the machine, like so. So we remove all this, like that. Echo looks good to me. To go ahead and take down the public key, like so. Copy, go to burp, paste this in here. Take out this bit, and then Control U to URL encode it. Hit send. Cool. I'll go ahead and SSH. Just move this out of the way. SSH. It will be their username. So I think it was like dasif or something like that. Yeah, dasif. I want that. Copy. At $box -I tilde //SSH ID RSA, and that should work. Cool, yeah, that works. So now we have access to the machine. Sweet. So the first thing I tend to do whenever I get access to a machine is get my enumeration scripts on the go. So we'll go to here, we'll go to the home directory, we'll go to CD, tooling, armory, Linux priv escalation. This has just a few tools in there, enum, linpriv. These basically will run Linux enumeration scripts, which will basically pull down potential priv escalation vectors. I'm going to run lcweb, which is a script I made, very simple, just basically gets all the files in the current directory, prepends curl, and then basically pipes the output of them into bash, basically meaning that I can run this line and it will download the file and run it and then put it into a directory, which is just very nice. Cool, I'm now going to go and take these two, which are the ones I wanted. Sweet, we'll go ahead into cd temp, but before we do that, we wanted to check the current directory. Nothing in here, nothing in here. Okay, pretty normal. Okay, cd temp. Cool, now we'll run the scripts. What this will do, basically, like I say, we'll download the scripts and run them. If we now do else, we'll now see that we have an enum.sh out. When that has now downloaded, we should then have a hit enter. And then here we can see it's run some of the scripty bits. Now I'm going to leave that to run for a minute while I go ahead and manually try and solve the machine. Okay, so we're in this directory. Now the enumeration scripts will do this for me, but as an approach of trying to see basically what I can do just as a manual attempt is to find out first of all, okay, so I'm running it as a user. What can I run that may give me escalation to priv escalation? Quite commonly, I will look for find, which will basically find all the files in the file system, and then add -perm, which means all the permissions, dash to say what permission, and then O4000. This will basically look for all SUID binaries. Now we're going to get some errors here, and that's going to get in the way. So I'm now going to do 2 angle bracket dev null. This will pipe all the errors out where it says like permission denied to basically out of the way, put them in the bin. Okay, cool. Now we scroll up and we can see here we have some very default binaries that have the SUID bit enabled, like password, for example. When you do like change a password, you're actually using a SUID binary. But here we have a opt count. Interesting. Let's go ahead and check out opt. So we have a code.c, account, and a valgrind.log. Okay, cool. Let's go ahead and take the code.c. I'm going to go ahead and basically save this into my own VS Code just so I can read it and it's just a bit easier. Cool. Pro.js, new, we'll call it code.c. Doesn't matter that it's in that directory. Cool. Now we can read it. Okay, sweet. So let's start from main. Having a quick read through the main function, which is called upon instantiation of the program. So basically it's first when I go ran. This basically takes in some variables, for example, the path and summary, storing it in that there. Then we have basically some user input that says, hey, enter a file name or a directory. We're then checking if the file name or directory is a directory. If it is a directory, we pass it into this function, which is up here. If it isn't a directory, we pass it into this function, which is here. Okay, cool. So let's check out dir count, since that's the first function that gets called potentially. Basically just finding some variables and that kind of thing. We're opening the directory, seeing if it fails, reading the directory, looking through it, checking if it's a directory, then basically going through more of them, checking if it's a link, basically just printing out what's in there really. Nothing that interesting, it's just literally printing out what's in the directory, the same as like the ls command would do, like so. Very simple. However, if we look at the file count, kind of similar, except in this case, we are opening a file, so basically it checks if the file exists or not. If it doesn't, it throws an error, and then it opens a file here. You can see here we have file equals f open, and then the path to the file. Now, The reason this is important, and the reason we're looking at this, is because this is a SUID binary. If I now do ls-la, you can see here that it is red, meaning that it is a SUID binary. And when it's a SUID binary, which is this S here, and it's owned by root, meaning basically when you run this file, it actually runs as a root, and not as the user that you currently are, so -if in this case. This is just from the enum stuff that I'm running. It will disappear soon enough. But basically, it won't be running as -if. It will be running as root. So if I do ID 0, I think it is, it will then show me root. Basically, it will run as root. However, if we scroll down a little bit more in the code, we notice that after this has ran, we then have a setUID getUID, which basically means drop the privileges to the current user. For example, -if, which basically means we're not really getting any more than ls or a cat. So we need to basically exploit this bit of code before it can drop our privileges. Luckily for us, this file count here does a privilege action of reading a file. Let's go ahead and test that first, though, because we actually want to test our assumptions. If I now do /count like that, it's going to say enter source file directory name. Now, if I do say /shadow, I can't read /shadow as a non-privileged user, as a non-root user, but yet this can. It says there's 1,187 characters in there. If I now try, say, another one, so if I now say count and do password, which I can read, different number of characters, basically meaning that it's reading a privileged file, and obviously we can't normally, but it's allowing us in this case since this is a SUID binary. Okay, cool. So where's the attack path here? Now, I haven't done so much of this stuff, but basically my thoughts were, if it has a file open, it will be storing the file in memory. And if I can kill it while the file is open, then I might be able to retrieve what it had stored in memory, in principle. So I did a little bit of Googling, and I found a nice way to effectively kill a process where it would dump the output of memory into a file. This basically creates a segmentation fault to the best of my knowledge. So we'll go ahead and do that. So first of all, we need to pick the file we want. Now, I ran you through before the SSH keys. If we have the ID RSA key, for example, try and pull an example down here. If I have like the ls SSH ID RSA, if I have that file, I can most likely log into the machine as the owner of the ID RSA. If this gets leaked, they can log in as Kali. If the root user's version of it gets leaked, they can log in as a root. So I want to basically tell the file to run this, and I want to go /root .ssh ID RSA. Enter. Cool. And that tells me here that it exists. Total characters 2,602. If I were to then say do like WC, which is like word count, I think, we would then get a number 2,590, 2,602. Basically the same. Same number of words roughly and lines. So yeah, okay, cool. So that exists from what I can see. Now, this is currently holding that file in memory. Because it's saying save results to a file. In the code, it is basically telling us, do we want to save it to a file? And that means that it's holding it in memory, which means we can effectively kill it just before it dumps that memory. So how do we do that? Well, we can use kill. But before we can kill, we need to basically background the process. So we can go ahead and do that. Just an easier way than opening up a second terminal. That has now backgrounded the process. Okay, we can then do kill -sig segv, which basically means like segmentation fault, I believe. However, we need the ID, so we do ps, which gets us the ID. Count, we want to use this PID here, so we want to go kill here. That's now ran. Cool. Now if we then do fg, which is basically drops back into this process, into this count process, we're going to get an error, segmentation fault, core dumped. That basically means that because the application had a segment fault, it died, and therefore it dumped all of the contents of what was in memory to a file. And that file is stored in, I believe, cd var crash. Yep, I think so. And then here we have this one here. Now, if I do ls-lat, which basically puts it in order of the most recent, in this case we have opt count 1000 crash. That's one I want. And now I'm going to go ahead and run a port unpack. what this will do basically is it will just convert this binary data into a file that is readable, at least to a better degree. Okay, and then we can tell where to output it. In this case, I'm going to go temp crash, like so. Cool. Now I'll do cd into temp, and we should now have a crash folder. See, cd crash, a bunch of directories. Now the sigzeb we ran meant that the core was dumped, and you can see it here. When it died, we have a core dump. So you want to look into the core dumped folder directory. I'm going to run strings on core dump, like so. And here we can see basically all of the data that was in memory at the time. For example, you know, the current home of the user and all that kind of thing. But if you scroll up and up, you can see here we have an open SSH key. And that open SSH key is what was in memory when we ran the file. So you can see here that this is on the standard output, save results to a file, total lines 39, and then we have here like the name of the file we gave and that kind of thing. We'll go ahead and take this because this was in memory, and we can then save that to a local file. So nano idrsa, wrong directory, box. Nano idrsa, drop that in here. Cool, new line it. Chmod 600, which will basically mean the privileges are right, root and box, like so. Hit enter, and we should be root, which we are. See, cat root rot root.txt, and boom, solved. So hopefully that quick little video helped. If you enjoyed it, like, comment, subscribe. Apologies for the delay in my videos recently, everyone. I've been busy with work stuff and certification, so I've not had the time. But like I say, if you enjoyed, like, comment, subscribe, and I will see you next one. Take care, everyone. Bye.